Dcfldd versus Dcfldd vs Dd. What are the main differences between Dcfldd, Dcfldd, and Dd? In what situations would you use one over the other? Why are there three different yet similar programs?
The three are different, and the two variants are derived for the needs of specific communities. Dd is a general-purpose software for imaging. Ddresq is designed to rebuild damaged files from multiple passes and sources, and forensic Dd variants are designed to make verifiable, legally sound copies. Dd is the baseline version, it's the generic product, so to speak. Dd is designed to make a bit-perfect copy. It's what you use when you want to make a disk image, with no fancy add-ons. Dd does one thing well, and absolutely nothing else. While there's distinct new and BSD versions, their functionality and commands are identical to both the Unix Dd and a previous software made for the IBM JCL. Dcfldd is optimized for data recovery. It will note down where bad sectors are, and will attempt to fill in those areas with data from subsequent runs. As a result, the aim is to get files that are readable, as opposed to bit-perfect. You will want to use it to recover data from a drive you suspect is damaged. To confuse things, there's an older Dcfldd which is not as advanced or easy to use, so check which one you're using. On Ubuntu, Dcfldd is installed by the package Dcfldd, and you want this, not the older Dcfldd package, and is invoked by the command Dcfldd. From the Ddresq webpage. Dcfldd does not write zeros to the output when it finds bad sectors in the input, and does not truncate the output file if not asked to. So, every time you run it on the same output file, it tries to fill in the gaps without wiping out the data already rescued. Automatic merging of backups. If you have two or more damaged copies of a file, CD-ROM, etc., and run Dcfldd on all of them, one at a time, with the same output file, you will probably obtain a complete and error-free file. This is so because the probability of having damaged areas at the same places on different input files is very low. Using the log file, only the needed blocks are read from the second and successive copies. Dcfldd and other forensic Dd variants are designed to make forensic copies. These need to be bit-perfect and verifiable. Use this when you absolutely need to know that a copy and subsequent copies are identical to the original. Forensic Dd variants add additional features such as hashing. From the website, additional features of Dcfldd are: hashing on the fly. Dcfldd can hash the input data as it is being transferred, helping to ensure data integrity. Status output. Dcfldd can update the user of its progress in terms of the amount of data transferred and how much longer operation will take. Flexible disk wipes. Dcfldd can be used to wipe disks quickly and with a known pattern if desired. Image/wipe verify. Dcfldd can verify that a target drive is a bit-for-bit match of the specified input file or pattern. Multiple outputs. Dcfldd can output to multiple files or disks at the same time. Split output. Dcfldd can split output to multiple files with more configurability than the split command. Piped output and logs. Dcfldd can send all its log data and output to commands as well as files natively.